Ever look at a construction site or a big factory and wonder how it all works without things going wrong? Well, it's not by accident. There's this invisible shield protecting everyone. And today, we're going to peel back the layers of that shield and really dig into the science of keeping people safe.
And this is where it gets really interesting. One of the core ideas from our source material is this quote: "The last line of defense is PPE." Now, PPE is just personal protective equipment. You know, the hard hats, the safety glasses, the stuff you notice first. But think about that phrase, the last line of defense.
That just begs the question, right? If that's the last resort, then what are the first lines of defense? What are those smarter, more powerful layers of safety that are designed to stop a problem long before anyone needs a hard hat? That's the puzzle we're going to solve today.
To do that, we actually have to start at the end. We're going to look at that last line of defense first. Because once you understand why it's the last choice, you can really start to appreciate the genius of everything that comes before it.
Okay, this right here, this is the playbook. It's called the hierarchy of controls. Think of it like a ladder, where the most effective, most powerful solutions are at the top. You always want to solve a problem as high up this ladder as you can. You start by trying to totally eliminate a hazard. Can't do that? Okay, then substitute it with something safer. If that's not possible, you use engineering controls to physically separate people from the danger. After that comes administrative controls, basically changing how people work. And way down at the bottom, the very last option is PPE.
And here's why it's at the bottom. The catch with PPE is that it doesn't actually get rid of the hazard. Nope, the danger is still right there, just on the other side of your safety glasses or gloves. Its success depends entirely on a person using it perfectly, 100% of the time, without fail. And, well, that leaves a lot of room for human error. So let's climb one step up that ladder to engineering controls. This is where the thinking totally shifts. We stop trying to shield the worker from the dangerous environment, and instead we start changing the environment itself to make it less dangerous.
And this is such a brilliant way to think about it. You've got passive systems versus active systems. A guardrail is a perfect example of a passive system. It's an engineering control. It's just there. It does its job 24/7 whether you notice it or not. An active system, like a fall arrest harness, which is a type of PPE, does nothing on its own. It requires the worker to actively put it on, check it, and use it correctly. You can see why passive is almost always better. It's just more reliable.
So what does this look like in the real world? Well, you see them everywhere. Guardrails physically stop you from falling. Machine guards put a barrier between you and spinning parts. Those Lockout/Tagout devices? They're basically special locks that make sure a machine has zero power before someone works on it. Even ventilation that sucks fumes out of the air is an engineering control. See the pattern? They're all physical changes to the space that just work on their own.
And look, this stuff isn't just a nice idea, it's often the law. In the United States, for instance, OSHA says you need fall protection if you're working 1.2 meters, that's about 4 feet, or more above a lower level. And what's the preferred method? It's not a harness, it's a passive engineering control, like a good old-fashioned guardrail.
Okay, now we get to the very top of the hierarchy, the absolute peak of safety thinking. This is the most elegant and the most effective solution of all. This is where we stop asking, how do we protect people from the hazard, and start asking, wait a minute, why do we even have this hazard in the first place?
And that is the whole game right there. Elimination and substitution. It's a pretty simple concept when you think about it. Instead of building a fortress around a dragon, you either figure out how to get rid of the dragon completely, that's elimination, or you swap it out for, a puppy, that's substitution.
Our source material gives this fantastic real-world example. For years and years, water treatment plants used chlorine gas, which is incredibly toxic. The danger of a catastrophic leak was just always there. So what did they do? They substituted it with sodium hypochlorite, which is basically a stronger liquid form of bleach. It's way safer. They didn't just manage the risk, they got rid of the original terrifying hazard altogether. Problem solved.
Okay, so that whole hierarchy, that's the strategy. That's the what. But how do you actually do it? How does a big organization put all this thinking into practice? Well, it's all part of a very deliberate plan, a blueprint for safety.
And it turns out every truly effective safety program is built on 5 core pillars. You have to have leadership from the very top, and you need participation from the workers on the front lines. You need a solid system for identifying hazards, and then you need great training to educate everyone. And finally, and this is key,
You have to constantly evaluate and improve the program. You can't have one without the others. Now, to build that program, everyone's got to speak the same language. So let's get specific. A hazard is the thing itself. It's the potential source of harm. Think of it as the puddle of water on the floor, the unguarded blade on a saw, or the toxic chemical in a barrel. Risk, on the other hand, is the chance that the hazard will actually hurt someone. So how likely is it that someone will actually slip on that puddle and get injured? That's the risk. Understanding the difference is crucial because it helps us prioritize. We use that hierarchy of controls to go after the highest risk hazards first. All right, and this brings us to what might be the most important idea of all. A great safety program isn't just a set of rules in a binder that collects dust on a shelf. The very best ones are dynamic, constantly adapting, they're alive.
I just love this quote from the source material. A safety program must be treated as a living document. That means it's always learning, always getting better. A smart program tracks two kinds of things. It tracks lagging indicators, like how many accidents happened last year. That's like looking in the rearview mirror. But more importantly, it tracks leading indicators, like how many safety trainings were completed. That's like looking at the road ahead, trying to prevent the crash before it ever happens.
And that pretty much wraps it up. It's a completely different way of seeing the world around you, isn't it? So I'll leave you with this question to think about. The next time you're just going about your day, take a look around. From the guardrails on the highway to the automatic shutoff on a gas pump, what invisible safety systems are quietly working in the background, protecting you every single day?